Students, let's talk about Arrhenius equation. This is k equal to a e to the power minus ea by rt, where I know that k is nothing but rate constant, a is nothing but, this is an exponential factor, so we call it as a pre-exponential factor. We can even call it as Arrhenius factor. This is Arrhenius factor, also known as a pre-exponential factor. Right? EA is nothing but activation energy. R is universal gas constant. T is temperature in absolute scale. Now, let me go ahead. What you do now, you take log on both the side. So, I am writing here it as log to the base E, of course, at temperature T1, at temperature T1, here it's Arrhenius constant, e to the power minus Ea by RT1. So I have taken log over here also. Fine. Now what you do is you take temperature T2, K1 become K2, now what doubt arises? You may ask me, at temperature T1 you wrote rate constant K1, at temperature T2 you wrote rate constant K2, but why I have not mentioned EA1 and EA2? Let me explain that to you people. So let me clean the board. Okay. Now everyone write this. Along y-axis you show energy. Along x-axis you write progress of reaction. Progress means reactant to product. You show this point as the threshold energy point. If this is energy of reactant and this is energy of product and this is the profile of the reaction graph. Now everyone see this, the peak and the energy of reactant, this difference is called activation energy. And let me tell you people that as the activation energy more, crossing barrier become difficult, so reaction rate will be less. As the activation energy become less, more people can cross the barrier and reaction will be more faster. Got it? Now exactly what happened when the temperature is low. When the temperature is low, you assume that there are 10 reactant molecules, 10 reactant molecules, 5 and 5, right? At lower temperature you assume that these 5 molecules from the reactant state will become active and will reach the threshold energy point and will be able to give you product, right? Now when temperature become high, at high temperature, all reactant molecules will become active and will cross the barrier. That means when temperature was low, the number of active molecules was less, so that reaction rate was less. It is nothing to do with the height of the barrier. As you increase temperature, what happened? Number of molecules becomes active, become more. So more people reach threshold energy point and all of them give product, so that reaction rate become more. That means when you vary temperature, there is nothing will happens to activation energy, but rather that we have number of active molecules becomes more, so that reaction rate becomes more. That's the reason why for change in temperature, I have not shown energy activation change. It will remain same. So that is what we can see in this particular graph. Now let's go ahead. What I will do now, I will take it as expression 2 and I will take this as expression 1. What I will do now, I will do it as 2 minus 1, right? 2 minus 1 I will do. So what we have here, so let me elaborate this. What is log of A into B? It's log A plus log B everyone knows log e to the power x to the base e is x. Similarly, log e to the power minus ea by rt1 to the base e is minus ea by rt1. So everyone see this, log e power x to the base e is x. I'm using that result and I'll write here. This is nothing but minus into plus is minus ea by rt1. The similar thing I'll do here, log of A plus log B, log A plus log B, right? Now this minus this, everybody can see I'm writing it as it is first. This minus this. Right? What is log A minus log B? It's a log of A by B. Log of A by B. Everyone can see log A to the base E and minus log A to the base E gets cancelled. 1 minus 1 is 0. Now you can see what is left out, minus EA by RT2. Minus into minus become plus EA by RT1, right? Log K2 by K1 to the base E equal to, I can take EA by R common out. What is left out inside? 1 by T1, this one minus 1 by T2, right? Now what is 2.303 log to the base 10? Everyone knows it is log to the base E. So rather writing log to the base E, let me write 2.303 log to the base 10 K2 divided by K1. This is equal to EA divided by R, common in denominator T1 into T2. So in order to get T2 here, you should multiply T2. So multiply T2. In order to get T1 here, multiply T1, multiply T1. So this is what we get. And this 2.303, you shift it another side, that will go to denominator, that will go to denominator. and this is what the final expression that we get. Log K2 by K1 to the base 10 is equal to EA divided by 2.303 R T2 minus T1 divided by T1 into T2.